Hello everyone and welcome. In this video we're going to be talking about 5 things you should never do in an automatic transmission vehicle. And this is kind of a follow-up to the video I did, 5 things you should never do in a manual transmission video. And I think just as important as to understanding, what you shouldn't be doing is understanding why. So I brought some parts along. This is part of a torque converter. And so we're going to be looking at, kind of how mechanically automatic transmission works. So the first one we're going to talk about is that you should never put your vehicle in neutral when you're coasting down a hill. And so the logic behind this may be that, you can save fuel economy by putting it in neutral and coasting down the hill. And let's say you're on a tall hill and you're about to go over a shorter hill. If you put it in neutral, you can gain a lot of speed and gain enough speed to go over that smaller hill without, getting on the gas. And so you can save some fuel by doing that. But the other thing is when you do have it in gear and you're coasting down a hill, modern transmissions and modern vehicles, what they'll do is they'll cut fuel to the engine. So you'll just use the wheels, which are connected to the transmission and thus the engine because it's in gear, to shut off the fuel injectors. And so the wheels will be powering the engine. And so in that case, you won't be using any fuel. So as you're going down that hill, you won't be using any fuel. And you can see this on fuel economy indicators. If you put it on neutral, it'll read something a little bit lower. And then if you put it in drive, then you can notice that the instantaneous fuel economy will go up to the highest number that it can read because it's shut off fuel from going into the engine. Moving on to number 2, whenever you're changing directions in an automatic transmission vehicle, you want to make sure you come to a stop before switching from drive to reverse or from reverse to drive. So backing up, come to a stop, then put it in drive, and then move along. And so the reason why you want to do this is because you're using your brakes to stop the vehicle rather than your transmission. Your transmission is designed to shift gears. Your brakes, on the other hand, are designed to stop the vehicle. So this is an automatic transmission band, and what this does is it clamps down around the housing of a planetary gear set. And when you do that, you alter the gearing of the planetary gear. So when you're in reverse or drive, this may be open, and then when you put it into the other one, it'll clamp down on a drum. So this works a lot like the reverse of a drum brake. So instead of pressing out like a drum brake, this squeezes down on a drum. And so what you're doing when you change that direction is you'll be using these bands as well as clutches. Automatic transmission also have multi-plate clutches within them. And so when you switch gears, these bands will clamp down to change the gearing. And when it does that, you're using this material here on this automatic transmission band to stop your car rather than the brakes, which are very easy to service and cheap to replace, versus this part, which was only $18, but very difficult to access. So it's going to take you a lot of time to replace it or a very expensive repair. So come to a stop and then put it in the gear that you need to go in. Number 3, we're going to talk about launching your... So one of the methods I've seen that people have done is they'll rev it up in neutral and then they'll drop it into drive and let that carry their car forward. And so that's kind of a dangerous way of launching your vehicle. And we're going to get into why using some parts. So here we have a torque converter, and this is the pump or the impeller. And so what you're going to have is the engine, which is going to be connected to a flex plate, and that flex plate is going to be connected to this. So this has been cut off so that we can see the inside of this torque converter, but know that this is always going to be rotating with the engine. So this is the pump, or you could call it the impeller. And within this, we have the stator, which we'll go ahead and set aside. What that does is it reverses the direction of the fluid when it's transferring between one side from the pump to the turbine. And so here we have the turbine, and so you can see an internal spline there, and this is what's going to be rotating with the transmission. So this will be splined with the transmission. As the impeller rotates, it will force this turbine to rotate, and as the turbine rotates, it will rotate the transmission and thus the wheels. So this is a fluid coupling, and so what that allows you to do is have a difference in speed between your transmission and your engine. So your engine can be rotating and your transmission can stay stationary, as I'm demonstrating here. So this is connected with the flex plate, and as that rotates, you can see the transmission can be held still. So when you're at a stop, that's what will be happening. This will be rotating and the turbine will just be stationary because it's connected to your wheels, which are not moving. So when you launch and you rev it up in neutral and then you put it into drive, what you're doing is you're going to be having friction between this this band and the drum which it's resting around as that tries to clamp down to send power through it. And so you're going to have clutches and bands within your automatic transmission that are going to be trying to absorb that power, but you're going to have slip because you're sending so much power through it. And these are designed to shift gears, not to handle a launch. And so you're sending power through it and you're going to be wearing out this band. As I mentioned, it's going to be very expensive to replace it. Moving on to number 4, there's no reason to put your car in neutral when you're sitting at a stoplight. It's fine to leave it in drive, and that's something that some people will commonly do, is take it out of drive for several reasons. They may think, okay, it's putting a lot of stress on your transmission. But let's think about that for a moment. If you're sitting there with it in drive, and so your engine is spinning, and my hand, which is touching the turbine, obviously isn't moving, so your engine's spinning, this isn't, so you're putting some stress on the transmission. And yes, that's absolutely true, you are doing that, but let's think about it. Once you let off the brake and you start accelerating, you're putting a far greater force into that turbine to move your vehicle forward than if you're just sitting there with your engine idling and it's trying to put some of that energy into the turbine. So really, you're not putting any additional stress on it. It's far less than you are when you're actually accelerating. So it's kind of crazy to think, oh, I shouldn't do that. Moving on to number 5, you should never put your vehicle in park until you've come to a complete stop. Now, here's the thing. Most automatic transmissions, especially modern ones, will not allow you to do this, but it's cool to understand why. When you put your vehicle in park, you're applying a pawl, essentially a locking pin, into a gear which is connected to your transmission's output shaft. Your driven wheels are connected to the transmission output shaft, so when this is locked, your wheels cannot move. Now, if you were to engage the parking pin while the vehicle is moving, and there weren't systems to prevent this from happening, you could very easily shear the locking pin and break it as it attempts to completely lock up a transmission in motion. Either way, you'd be putting a huge amount of stress into your drivetrain and transmission.